Hi everyone, this PowerPoint presentation and video will discuss how to fly with IFR weather and also flight planning. So of course before you go fly you're going to need a thorough weather briefing. Once upon a time weather briefings were done person to person like you see here at this flight service station. That is a long time ago. That's when I started flying. Nowadays everything is done on the internet basically. We do our pre-flight planning using various weather packages or pre-flight planning packages such as ForeFlight or FlyQ or various other sources. Also the Lockheed Martin flight planning services are also very valuable and very helpful. So whenever you fly, make sure you have plenty of gas in the tanks. Of course you want to have enough fuel in your tanks to get to your destination, and then an alternate. Then typically you want a little bit more, of course, after that. You know, there are regulations, but of course we all have our own personal minimums. So make sure you have plenty of fuel in the tanks. And then also file IFR whenever you can. If weather starts closing in on you and you're instrument rated and you're not on an IFR flight plan, go ahead and get an instrument clearance. Just call up air traffic control in your local area and they will help you to whatever extent they can. Also, as you fly along, you should get en route weather updates. Sometimes your destination will go below minimums if you're flying IFR, and sometimes your best alternate is the one that you're flying over at that time. So make sure you get plenty of weather updates whether you're flying IFR or VFR. And that's pretty easy to do if you have ATSC. Otherwise, you're going to have to get on the radio and either listen to AWOS stations ahead of you, or you might have to call flight service station to get updates. Also, you should not scud run. Remember that VFR into IMC causes the highest percentage of fatal accidents. You don't want to be a statistic. So if you do end up in a condition like that, then you are going to have to commit yourself to flying IFR. So that takes a very conscious decision. You want to keep flying and looking outside, but you should rely on your training and go to the gauges. I know that these are steam gauges, but of course we have glass now and you can use the glass, and that's very helpful. You know, if you inadvertently encounter IMC, probably the best thing that you can do right away is make a very gradual 180-degree turn to exit the conditions if the conditions you left were good VFR. If they're not, then you have to consider other options. And the other options are to climb. If you're in IFR conditions and you're close to the ground, scud running, you're going to run into something. So it's best to climb. And then the FAA uses the 5 C's. Circling is not necessarily good in IFR conditions, but you do want to climb and at least communicate with the ATSC and tell them your problem, and then let them help you by complying with their instructions. Okay, so flight planning. We're going to talk about really looking at IFR weather patterns and also looking at METARs. First off, you should make sure that you remember all the symbols that are used for IFR conditions that obscure the sky. Light fog is no longer called light fog. Of course, it's mist, but all the other things, you guys should be familiar with those symbols. You may see that on the exam. Also, you should be familiar with the contractions that are used in the METARs for various obscurations, and also the qualifiers that are used before them. And other things you should know about low ceilings and low visibilities. Of course, with the low ceilings, follow the trend. Watch what the METARs are doing. And remember that weather conditions that are low IFR are not well forecasted. Remember, the models are not very good, and the meteorologists are doing the best they can, but a lot of times when the visibility and ceiling, or when the ceiling drops below 500 feet, they're basically throwing darts. And with low visibility, remember, always check the temperature dew point spread. That gives you an indication of worsening conditions. And then if you have an overcast sky, above a fog, that means that the solar radiation is not able to get through and reach the ground and burn the fog off. So expect the fog to stick around if you have overcast at higher altitudes. That's where satellite is invaluable, looking at the conditions higher in the atmosphere. And then, of course, if it's raining or drizzling, that's adding moisture to the atmosphere, so fog won't get any better. And also remember that low IFR conditions are not forecasted well either. We said that low ceilings are not, and low visibilities are not forecasted well. And then also, if you have a high pressure system over a region and you've got haze or smoke or things like that, high pressure usually implies subsidence and also inversions, and those can cause the haze and the smoke to stick around for a while. One other thing that you can do is follow the trends in the METARs to see what's happening to temperature, dew point, wind, the ceiling, and visibility. So we talked about forecasting with trends, and forecasting with trends is good in the short term, but usually not good in the long term.
Following trends in meteorological properties, you can determine what kind of fog is occurring. For radiation fog, some of the things you look for in the METARs is the time of day. Typically, radiation fog happens late at night or early morning hours. Also, you're looking for winds that are light or calm, meaning winds that are between, less than 5 to 10 knots. They could be dead calm and anywhere up to 9 or 10 knots, and still radiation fog may form. Of course, temperature goes down to reach the dew point or meet the dew point, so temperature is decreasing. The dew point really doesn't change a lot. It might change a degree or two. The sky condition goes from a clear sky to overcast or vertical visibility as the visibility decreases. And of course, the visibility decreases until sunrise, and even just a little bit after sunrise it might decrease. Typically the fog is the thickest right after sunrise or an hour after that. And then it gets better as the morning progresses. Here's an example of radiation fog. We've got several METARs, 4 different METARs. The oldest one is up top and the newest one is on the bottom. These METARs are occurring early in the morning at 6:53, 8:53, 10:53, and then finally 12:53 in the morning. And you notice that the winds are not real strong. They're only about 6 or 7 knots. They're out of the east, whatever that means. But the visibility, as you can see from the late night or early morning hours until just after the sun rises, visibility is dropping progressively. Starts out with clear skies, goes mist, and then finally mist with vertical visibility of 300. Temperature starts out at 23 and ends up at 17, and it meets the dew point, which is at 17. So this is a good example of radiation fog. The trend that you're looking for advection fog, there are a few things that'll help you pick or tell that from the METARs that you have advection fog. One of them actually is geography. You can't tell that from the METAR, but if there is a station that's very close to an ocean or bay or something like that, they tend to get more advection fog. So look at the climatology of advection fog. Also, the time of day actually can happen anytime. It doesn't have to necessarily happen early morning hours or late at night, but typically it does get a little bit more dense and it's enhanced in the early morning hours. Winds are typically steady and usually a little bit more than 10 knots. Maybe you'll see something like 12 or 15 knots or thereabouts. If you get more than 15 knots, then you're going to start to see more of a stratus or stratocumulus type of cloud cover. Temperature typically stays the same or maybe even increases a little bit because warm, moist air is moving over a colder surface. So at a given location, you'll notice that the temperature increases because warm air is coming in. Dew point also increases because the mass of air coming in from the ocean tends to be a little bit more moist. Sky condition typically is not clear at the start. It might be broken or overcast and then eventually go overcast and vertical visibility. with lower ceiling over time. The ceiling starts to lower. And then visibility, of course, decreases, and the possibility does exist for a rapid decrease in visibility sometimes with the onset of advection fog. Here's a good example of advection fog coming from the JFK, just outside of New York, and this sits right on the Atlantic Ocean. You can see that this happens throughout the day. From 12:45 Zulu all the way until 20:54 Zulu. The winds are not extremely strong, but they are steady. 8 knots, 11, 15, 16 knots. Visibility steadily decrease. Starts out as a scattered sky and it goes overcast at 900 eventually. Notice that the temperature does go up a little bit, but the dew point is what is significant. You see moisture coming in and advecting in, and the dew point starts out at only 4 early in the morning, and then by afternoon it's up to 15. So this is a good example of advection fog. Precipitation fog happens anytime there's precipitation falling, and of course visibility is starting to decrease. As the precipitation falls, it evaporates, saturating the air. So also you'll notice that the temperature may decrease because of that evaporation. It takes energy to evaporate or sublimate the precipitation that's falling. Also, dew point will increase because you're adding moisture to the air, so the dew point goes up to meet the temperature. Sky condition, it starts out as broken or overcast because there is precipitation falling, so you need a thicker cloud deck to have precipitation. And then, of course, visibility decreases. Here's an example of precipitation fog, and this is happening early morning hours, and there's not a big distance between or big time difference between these two METARs. Just shows that there is precipitation falling. Here you have light rain and mist with lower visibilities of about 1.25 miles to 1.5 miles. And of course it shows the ceiling is kind of ragged, and shows you also that the precipitation started a little bit earlier. So they are getting low cloud cover and lower visibilities because of this precipitation. And then finally, last one we'll talk about is ice fog. Ice fog happens at very cold temperatures. We're talking temperatures of minus 30 Celsius. So this only happens in northern climates. You're not going to see minus 30 degrees Celsius in Florida, are you? So look at the station. If it starts with a C, you know you're in Canada. In Canada, it gets cold up there. So you may have ice fog up in Canada. Alaska is PA. It starts with PA, so if you see PA at 4 letters with the station identifier PA, then you know it's in Alaska. Winds are typically calm. It's very similar to radiation fog, just at a much colder temperature. Of course, the visibility decreases. The type of weather, you'll see mist reported, or perhaps icy for ice crystals, or even fog. Temperature and dew point are just very cold, and they'll be usually a degree apart or less. Maybe they're the same number. And then sky condition, of course, typically starts out as a clear sky, but then as the visibility drops, you might see overcast or even going to a vertical visibility. Here are examples of ice fog. As you can see, the winds are light, only 4 or 5 knots. It is a station CYYQ, so that tells you right away that it's in Canada. This is happening early morning hours, 8Z, 10Z. And then also the visibility starts dropping. You see IC, which stands for ice crystals, but you have a clear sky. Eventually you get mist. Look at the temperatures, minus 30, minus 32, and minus 34. And eventually temperature and dew point do get within 1 degree Celsius of each other. So those are some ways to distinguish between the different types of fog.